notation and rounding off. You have to know why we are using this scientific notation, because there are some numbers and with indices we can express the numbers, but scientific notation is more important when we are dealing with the huge numbers. For an example, 1 million, 10 millions, or 100 millions, billions. In those cases we cannot write them. No, for an example, if I write like this, okay, how can we read this? It's little difficult to read this number. No? So that's why we are using the scientific notation method to make it easier to read high numbers. Okay, to make it easier to read huge numbers. That's why we are using scientific notation. For an example, for small numbers also we can write the scientific notation. 0.000573215872 likewise. How can we read this? It's little, it's not little, it's very very difficult to read these numbers. That's why, to make it easier to read, we are using scientific notation. Let's start from the beginning. If I give you a number, mm, 212, how can we write that in scientific notation? First of all, you should express this number as a number. Okay, you should express this one as a value in between 1 to 10 and with its corresponding 10 power. I'll repeat again. You should write this number as a value in between 1 to 10 and its corresponding 10th power. So when I tell like that, it looks really difficult, complex to understand, but actually it's not that difficult, really easy. Look at this number. It does not have any decimals, no. So that means the decimal is located in last of this number. So when I place the decimal here, actual decimal place is after the number. So when I read like this, it is 212. I don't need a number like that. I need a number in between 1 to 10, in between 1 to 10. That's my first conclusion. So that means I have to express this number as a value in between 1 to 10 first. So for that we have to move the decimal place. So when I move the decimal place to one digit left hand side, it will become 21.2. Now also this is not in between 1 to 10 range. This is greater than 10. Now I have to move this decimal one more digit before. Now look at this. Now the number is 2.12. 2.12. That means this is the number in between 1 to 10. That is the first thing you should do. Just express the given number as a value in between 1 to 10. I have expressed this as 2.12. The decimal is moved 2 digit left hand side. That means 10 with the power of 2. The decimal is moved 2 digit left hand side. That means 10 with the power of positive 2. That's all for our scientific notation. Okay, I'll repeat the same thing again. So when I give you a number 212, how to express this one in scientific notation? For that, first of all, think where is the decimal is located. There is no any decimals given, so you should determine the decimal is located after the number. So 212, it is not a value in between 1 to 10. So that's why I am changing the decimal places. When I place the decimal here, it will become 21.2. Now also this number is not in the region 1 to 10. Again also I have to move the decimal place to left hand side. Now it became 2.12. That means that is satisfying the condition of the value in between 1 to 10. Thereafter, how many digits we have moved our decimal? 2 digit left hand side. Left hand side means it would be positive 2. Okay, 2.12 multiplied with 10 with the power of positive 2. That's all for our scientific notation. I'll explain by using another number. Okay, in this number, look at this. So this is also a huge number. 57,417.2. First of all, you have to express the number in between a 1 to 10 value. I will move the decimal. When I move the decimal one digit, it will become 5,741. We don't want that one. Again, I'll move the decimal another digit. So it will become 574 something. Again, also I'll move 57.417. That's also not satisfying the condition 1 to 10. So again also have to move the decimal one digit. So now we receive 5.74172. Don't worry about the decimal places. It should be in between 1 to 10. That condition is satisfied. No, 5.74172 multiplied with 10 with the power of, we moved already in the given number, the decimal is located here. Okay, located near to 2. So how many places we moved the decimal? 1, 2, 3, 4. So 10 with the power of positive 4. That's all for our scientific notation. To read and to make it easier for calculation, by using the huge numbers, we are expressing them in scientific notation to make our job easier. That's the explanation about scientific notation. So actually, if there is no any decimal given, you should conclude the decimal is located in last of that number. If there is any decimal given, really easy to write the number. We will look at another example. 7.5. Okay, how to express this one by using scientific notation? This is this number. Look at this number. This number is already in 1 to 10 region. Already in 1 to 10 region. So decimal, we do not want to move the decimal either right hand side or left hand side. So 7 with the power of 7.5 multiplied by 10 with the power of 0. That is the way you should express the given number, because that is already in the region, in the range between 1 to 10. So no need to convert that again. Write the exact number multiplied with 10 with the power of 0. That means there is no any changes in its decimal place. That is a constant. Yeah. So in the first number, the decimal is located last. Have to move this 1. It's 424, 42.40, 4.240. So 4.240. If there is any 0 in here, after that, if you don't have any values, no need to write that again. You can keep it as it is. Okay. So that means if there is any 0, after that you don't have any definite values. Zeros are called as non-definite values. You don't have any non-definite values. You can express it as 4.24. It's there is no any compulsory to write 0 here. If you have any numbers after this, you should write the 0. If not, you no need to indicate the 0. I moved the decimal 3 digit left hand side. It would be 10 with the power of positive 3. For the next question, already the decimal in here have to move one digit. So it will become 3.47 with the power of 10 plus 1. Here 1, 2. So 2.193, you should write all these numbers because these are definite values. Multiplied with 10 with the power of positive 2. Even though it has many numbers, we moved the decimal only 2 digits left hand side. So power should be positive 2. Look at this. This number only given as 6. So you should write this one as 6.0. Okay, keep it on mind. It does not have any decimal places. No, the decimal should be here. So 6.0. No need to multiply this by using any 10 powers because the decimal does not change anywhere. So 10 with the power of 0. So you must keep it on your mind that if there is only a number given, you should write that a single number. No? So 6.0. This is the way you should write. Not write like this 6 multiplied with 10 power of 0. That is not the proper way in scientific notation. You should use 6.0. Keep it on mind. Thereafter, in the next question, 1, 2, 3, 4. Decimal should move 4 digits. So 3.348154 multiplied with 10 with the power of 1, 2, 3, 4. 4 digits, positive 4. In the next question, I told you that without any definite values, you can neglect the zeros. The decimal is in last. 1, 2, 3, 4, 5. So you can write 2.8. No need to write 2.8000 because zeros are non-definite value. 2.8 times 10 with the power of positive 5. That's easy. Yeah, 1, 2, 3, 4, 5. 5 plates. Then last one also 1, 2, 3, 4, 5, 6, 7, 8. So 4.94, 10 with the power of positive 8. Here also no need to indicate the zeros because zeros are non-definite values. It does not have any, it doesn't hold any values. So no need to write that.